This section 2, conditional probability and independence. Introduction. One of the most important concepts in the theory of probability is based on the question, how do we modify the probability of an event in light of the fact that something new is known? What is the chance that we will win the game now that we lost our first point? What is the chance that I am a carrier of a diabetic disease now that my first child does not have the genetic condition? What is the chance that a child will be a smoker if the household has two parents who smoke? This question leads us to the concept of conditional probability. In study sessions 1, you learned about 3 major approaches to the concept of probability. Some rules governing probability were also highlighted. Here you will learn the concepts of conditional probability and independence. Learning outcomes for study section 2. At the end of these study sessions, you should be able to explain the concept of conditional probability, explain the concept of independence, solve problems related to these concepts. Conditional probability. Let S be a sample space, A, a collection event, and P in dot bracket, a probability function. Then we have a probability space S, A, P dot in bracket. Definition 1. Let A and B be two events in A of the given probability space. The conditional probability of event A given event B, denoted by P A over B, is defined by P of B is greater than 0, equation 1. Example 1. 2 students are chosen at random from a class consisting of 18 boys and 12 girls. What is the probability that the 2 students selected are A, both boys, B, both girls, C, of the same sex, D, a boy and a girl? Solution. Let P1 to be the event that the first student selected is a boy. Let B2 be the event that the second student selected is a boy. Let B1 intersection B2 denote the event that the 2 students selected are both boys. Now follow the solution. Therefore, probability of both boys is equal to 51 over 145. 2. Let G1 intersection G2 denote the event that the 2 students selected are both girls. Then follow the solution below. Probability of both girls is equal to 22 over 145. 3. B1, B2 union G1, G2 is the event that both students selected have the same sex. P B1, B2 union G1, G2 in bracket is equal to P B1, B2 in bracket plus P G1, G2 in bracket. Since B1 intersection B2 and G1, G2 are mutually exclusive, therefore the probability that the students selected have the same sex is equal to 73 over 145. 4. B1, G2 union G1, B2 is the event that the 2 students selected are a boy and a girl. Follow the steps below. The probability gives 72 over 145. Example 2. A boy has 10 identical marbles in a container consisting of 6 red and 4 blue marbles. He draws 2 marbles at random, one after the other, from the container without replacement. Find the probability that A. The first draw is red, while the second is blue. B. Both draws are of the same color. C. Both draws are of different colors. Follow the solution below. Independence. Recall that P of A over B is equal to P of B is greater than 0. Definition 2. 2 events A and B are said to be statistically or statistically independent if and only if any one of the following conditions is satisfied. 1, 2, 3. It is easily shown that 1 implies 2, 2 implies 3, and 3 implies 1. See post-test 2. Therefore, P of A intersection B is equal to if P of A and P of B are non-zero. This implies that one of the events is independent of the other. In fact, P of A over B is equal to P of A. So if P of A, P of B is greater than 0 and one of the events is independent of the other, then the second event is also independent of the first. Thus, independence is a symmetric relation. Remark: two mutually exclusive events A and B are independent if and only if P of A, P of B is equal to 0, which is true if and only if either P of A or P of B is equal to 0. Also, if P of A is not equal to 0 and P of B is not equal to 0, then A and B independent implies that they are not mutually exclusive. Definition 2. Events A1, A2 to AN from A in the probability space SAP dot in bracket are said to be completely independent if and only if 1. P AI intersection AJ in bracket is equal to, for I is not equal to J. 2. P AI intersection AJ intersection AK in bracket is equal to, for I is not equal to J, J not equal to K, I not equal to K. 3. P intersection AI N I equal to 1 is equal to pi N I is equal to 1 P of AI. Note: 1. These events are said to be pairwise independent if pairwise independence does not imply independence. A and B mutually exclusive implies that they are not independent. Example 3. Suppose two dice are tossed. Let A denote the event of an odd total, B the event of an ace on the first die, and C the event of a total of 7. Are A and B independent? Are A and C independent? Are B and C independent? Solution: P of A over B is equal to half is equal to P of A. P of A over C is equal to 1 is not equal to P of A is equal to half. P of C over B is equal to 1 over 6 is equal to P of C is equal to 1 over 6. So, A and B are independent. A is not independent of C. B and C are independent. Example 4. Let A1 denote the event of an odd phase on the first die. Let A2 denote the event of an odd phase on the second die. Let A3 denote the event of an odd total in the random experiment consisting of two dice. Then, therefore, A1, A2, and A3 are pairwise independent. But P of A1 intersection A2 intersection A3 in bracket is equal to 0 is not equal to 1 over A is equal to P of A1, P of A2, P of A3. So, A1, A2, and A3 are not independent. Summary of Studies Section 2. In these study sessions, you have learned 1. The concepts of conditional probability and independence. Conditional probability is given by P of A over B is equal to 2. Two events, A and B, are said to be statistically or statistically independent if and only if any one of the following conditions is satisfied. A. P of A intersection B is equal to P of A, P of B. This is the end of study section 2. Thanks for listening.